Hi students, welcome to the Chem 300 series and the Properties and Structures of Matter video number 19, Trends in Chemical Reactivity. In the last video we looked at the electron configurations and that particularly that focus on the subshell notation and what was happening in terms of the number of electrons in the outer shell was one of the key points to tell us something about reactivity. But we also know that there are certain ways in which elements react with other substances that also tells us something about their nature and their relative reactivity. One of the substances that's most common is water. Obviously, water occurs all around the earth, in our bodies, in living organisms, and falls as rain. It's a very important compound on the earth. And it interacts with elements in one of three potential ways. The first way is that it's soluble, i.e. the element can dissolve in water. There's no particular reaction that characterizes the solubility of particular elements in water. But certainly substances, some types of gases, for example, are partly soluble in water, and so the water can actually contain a certain amount of that element in a dissolved or solute form. Of course, elements can also be insoluble, so cannot be dissolved in water. And we see this sometimes, certainly certain types of metals that are not in the third category can just simply sit in water. They don't dissolve, but they also don't react. And so there's quite a number of examples of these, such as low activity metals, and also things like sulfur. In fact, the property of sulfur not reacting with water is very important in a process called the Frasch process, but that's something that we might have a look at later on in the course. The third way that elements can interact with water is to react with them, and probably the most spectacular ones that we've seen are the active metals. These can react with water to form a salt, which is usually a hydroxide, and hydrogen gas, and sometimes quite explosively. Particularly the lower metals in group 1 will react with water in a very explosive manner and produce large amounts of hydrogen gas. So these three different interactions with water tells us something about the nature of each of these different substances in terms of their interactions with water. As I mentioned, the most spectacular of these in terms of the last category are the active metals. And we can write some equations to just very briefly, represent this process. So when lithium solid is placed into water, it will form lithium hydroxide and hydrogen gas. The lithium hydroxide is soluble, and the hydrogen gas obviously is a gas, so it will escape. Now, one of the important things about the salt that's formed here, the lithium hydroxide, is that it has a high pH. It is basic. High pH is basic, and therefore we can detect that this is occurring simply by adding a little universal indicator and watching the color change to a nice rich purple color. If we are to duplicate this process for both sodium and potassium, we find we have the same equations. But you may have already noticed that I have left out a very important step, liquid. Sometimes hard to think and speak and write all at the same time, but there they all are. And what I'm sure you've noticed is these are not balanced. Okay, I've got too many hydrogens and all sorts of things that are happening over here. So what I'm going to need to do is I'm going to have to just balance each of these. And one of the interesting things about writing the equations for elements in the same group is you see that the mole ratios, and this is something that we're going to look at a lot more in our next topic, are consistent 2 to 2 to 2 to 1. This is something just to note down for now, and it's definitely something we're going to be looking at in the next topic in particular. But this consistency shows us one of the important trends in chemical reactivity. Thanks for watching.